Hello everyone, this is Mr. McMillan and I'm here today with another instructional video. This is the one that I mentioned in the last one when we did classifying triangles and the triangle sum theorem. Today we're going to be talking about triangle inequalities, which deal with the three different sides as well as the angles of the triangle. So at times we will be given the lengths of three sides of a triangle and be asked to determine whether these side lengths form a triangle. To determine this, we must use the triangle inequality theorem. So the triangle inequality theorem says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so if you have two sides, and you add them together, they have to be larger than the third side, and that has to be true for every single one of them. So there are three different inequalities. So if the following inequalities are true, then the segment lengths form a valid triangle. And we're going to use triangle ABC over here as an example, okay? So our three sides are AC, CB, and AB. So that's how we're going to write ours, but we're also going to write it using the little letters here. A, B, and C are just side lengths, and those would just be replaced with numbers. So those could be, 7, 8, 12, whatever it needs to be. Okay, so our first inequality that has to be true, we have to take BC and add AC, and that has to be greater than the third side, which is AB. Simplified, that's A plus B must be greater than C. Okay. The next inequality that has to be true, BC plus AB has to be greater than AC. So in other words, A plus C is greater than B. And then the third inequality that must be true, AB plus AC is greater than BC. So AB plus AC is greater than BC. So that means that B plus C must be greater than A. Okay? Now, I will tell you, I'm going to show you the long way to do it, but there is a shorter way to do it, okay? And it should become very apparent when we start doing the examples why this is true, but for now we'll talk about that in just a minute, okay? So, if you look down here at our first 12, the first 12 problems here, these want you to determine whether the following three lengths can form a triangle, okay? So the way I always start this out, and this is going to be the way that ends up being the shorter way anyway, is to take the two smallest lengths of the triangle and adding them together and seeing if they're larger than the biggest side, okay? So let's look at this one. Number 1, 7, 6, and 1. So our two shortest lengths are 1 and 6. So we're going to take 1 plus 6. Well, 1 plus 6 is equal to 7. And then we're going to ask ourselves, is 7 greater than 7? No, 7's not greater than 7. 7 is equal to 7. So this is not true. So that means that no, this is not a triangle. Okay. All right, let's look at number 2, 7, 2, and 8. So we're going to take the two shortest sides. Our two shortest sides are 2 and 7. We're going to add those together. And we're going to compare them to the third side. So 2 plus 7 gives us 9. Is 9 greater than 8? Yes. So that one's good. All right, now I'm going to use 2 and 8 So 2 plus 8, that's equal to 10. Is that greater than the other side of 7? Yes. And we'll take 8 plus 7, that's 15, and obviously that is greater than 2. So yes, this is a triangle. Now, I do want to point out something. This is where I'm talking about the shortcut method comes into play, okay? If you have 3 side lengths and you're trying to see whether they form a triangle or not, the easiest way to do this is to take the 2 shortest sides, take the sum of the 2 shortest sides, and compare to the longest side. Okay. This will always give you the correct answer. If you take, now you notice here that we took the 2 smallest and we saw here. Well, if you had taken the 2 largest ones here, 7 plus 6 would give you 13, which is obviously bigger than 1. And 7 plus 1 would give you 8, which is obviously bigger than 6. Okay? That's why I always start out with the 2 smallest, the 2 shortest ones, because that will always give you a yes or no answer pretty much immediately. Because if the 2 shortest sides are not longer than the third side, there's no way for it to be a triangle in the first place. Okay, so take your the sum of the 2 shortest sides and compare it to the longest side. So for instance, in number 3, 8 and 10 are our short sides, so we're going to add 8 and 10. That gives us 18. And then we're going to compare it to 20. Is 18 greater than 20? No. So that means that this cannot be a triangle. We're going to do 3 more together, and then I'm going to cut you loose on these 7 through 12. Number 4, 13, 6, and 11. We take our 2 smallest sides, our 2 shortest sides. 6 plus 11. That gives us 17. And is that greater than 13? Yes. So that one's good. Now, I can tell you immediately that this one is going to be a yes. Okay? That's because the sum of the 2 shortest sides, if they are larger than the third largest side, the sum is, then that means it's automatically a triangle. You don't even have to do the other 2 inequalities. But just in showing you this, I want to make sure you see this. So 6 plus 13 is 19, which is greater than 11. And 11 plus 13 is 24, which is greater than 6. So they all check out. So again, take your 2 shortest sides, add them together, and if they're larger than the third side, you're good to go. You're golden. Apologies for the bell. All right, number 5, we have 9, 5, and 9. Now we have repeated sides here, so we only need to take one of them and do it. So we're going to take the 2 shortest sides, which would be 9 and 5. We're going to add those together. That gives us 14. And then we have this other 9 here. Is 14 greater than 9? Yes. So this is a triangle. Again, I'll show you. 9 plus 9 is 18, which is greater than 5. I mean, yeah. Then number 6, we take our 2 shortest sides again, 11, 18, and 16. 11 plus 16 gives us 27, which is greater than 18. So this is also a triangle. All right. So what I want you to do is I want you to try number 7 through 12. Determine whether those are triangles. Pause the video and then come back and check your answers. All right, let's look at number 7. 22, 7, and 15. So we take our 2 shortest sides, which are 7 and 15. So we're going to add those together. 7 plus 15 is 22. And then is 22 greater than 22? No, it's equal. So that means that this is not a triangle. Remember, it must be greater. It cannot be equal to it, okay? Number 8, 37, 20, and 28. We take our two shortest sides, add those together. So that's 20 plus 28, which is 48. Is that greater than 37? Yes, so this is a triangle. Number 9, 25, 20, and 46. We take our two shortest sides, add them together. So 20 plus 25 gives us 45. Then we compare it to 46. Is 45 greater than 46? No, it is not. So that means that this is not a triangle. Number 10, 3, 3, 3. Well, the only inequality to check is this one, 6 being greater than 3. That checks out. So yes, that would be a triangle. Anytime you see 3 side lengths that are exactly equal, those will always form a triangle. They'll always be equilateral. Number 11, 6, 7, and 14. Take your two smallest sides, which are 6 and 7. Add those together to get 13. Is 13 greater than 14? No. So this is not a triangle. And then number 12, 20 plus 7. So we take our two smallest sides, 20, and add 7. That gives us 27. Is 27 greater than 26? Yes. So this is a triangle. Okay. All right. Now, sometimes it will want you to do something a little bit different. So at times you want to determine the range of the third side when only given two sides. Okay. The third side must fall between the difference of the two sides and the sum of the two sides. So given lengths A and B, to find the range of length C, and sometimes we write it as X, we take A and B and subtract them. Now I'm going to write absolute value, but when we do this in the examples, we're always going to take the larger number and subtract the smaller number because the side lengths have to be positive. So this is your lower bound because you're doing the difference. And then you'll write less than. And then in this case, C, but sometimes we use X. And then less than. And then A plus B. Okay. So we subtract the two sides. That's our lower bound. Less than C, less than, and then we add the 2. That's our upper bound. So C has to come between those two. Notice how there is not an or equal to here, okay? C cannot be equal to either one of those values. So let's look at some examples down here at the bottom. Two sides of a triangle have the following measures. Find the range of the third side. So in number 13, we're given the sides 9 and 7. So we're going to have to do two things. We're going to have to subtract these two numbers and add these two numbers. That will give us the lower and upper bounds. So I'm going to write this as the inequality just all in a line, okay? So the way I'm going to write it, I'm going to take my larger number and subtract my smaller number. So 9 minus 7. Then I'm going to write less than X, and then less than, and then 9 plus 7. 9 minus 7 gives us 2, less than X, less than, and then 9 plus 7 is 16. So X has to be between 2 and 16. It can't be less than 2, it can't be more than 16, and it can't be equal to them either. Okay? Number 14, 5 and 4, we're going to take our largest and subtract our smallest. So 5 minus 4, less than X, less than, and then we take 5 and add 4. So 5 plus 4. 5 minus 1 gives us 1. less than x, less than 5 plus 4, which is 9. So 1 is less than x, which is less than 9. Number 15, 11 and 8, we're going to take 11 and subtract 8. And less than x, less than, and then we're going to take 11 and add 8. So 11 minus 8 is 3, less than x, less than 11 plus 8, which is 19. Number 16, we have two lengths, 22 and 14. We're going to take the larger number 22 and subtract the smaller number 14 first. And then less than x, less than, and then we're going to take 22 and add 14. 22 minus 14 is 8, which is less than x, which is less than, and then 22 plus 14 is 36. Number 17, we have 2 and 2. These are each the same, but that's okay. We can still subtract them. So 2 minus 2, less than x, which is less than 2 plus 2. 2 minus 2 gives us 0. 2 plus 2 gives us 4. So x has to fall between 0 and 4. Then the last example we're going to do together, number 18, 35 and 18. We take 35 and subtract 18. Then we take 35 and add 18. 35 minus 18 is 17. And 35 plus 18 is 53. So what I want you guys to do, I want you guys to try numbers 19 through 24, excuse me. And then come back after you pause the video and work those out and check your answers. All right, number 19, we have 6 and 13, so we're going to do 13 minus 6, and then 13 plus 6. So we have 13 minus 6 is 7, 13 plus 6 is 19, so x has to be between 7 and 19 for number 19. Number 20, we have 9 and 8, so we're going to take 9 and subtract 8. And then we're going to take 9 and add 8. 9 minus 8 is 1, less than x, less than, and then 9 plus 8 is 17. Number 21, 17 and 5, we're going to take 17 and subtract 5. Less than x, less than, and then we're going to take 17 and add 5. 17 minus 5 is 12. 17 plus 5 is 22. So x has to be between 12 and 22. All right, number 22, we have 18 and 1. So we're going to take 18 and subtract 1. And then we're going to take 18 and add 1. 18 minus 1 is 17, less than x, less than, and then 18 plus 1 is 19. So x has to be between 17 and 19. Number 13, 19 and 52. So we're going to take 52 and subtract 19. Then we're going to take 52 and add 19. 52 minus 19 gives us 33. And then 52 plus 19 gives us 71. And then finally, number 24, 61 and 54, we take 61 and subtract 54. And we take 61 and add 54. 61 minus 54 gives us 7. And then 61 plus 54 gives us 115. Okay? And so that's how you find the range. So remember, finding whether they can form a triangle, you have to add the two together and see if they're larger than the third side. You can just use the two smallest sides and see if they're larger than the third. And to find the range, you subtract your two sides and add your two sides and put them in an inequality. All right, And the final thing we're going to talk about today, which goes right along with what we just did, is ordering angles and sides of triangles. The relationship between side lengths and angle measures is shown in the figures below. Take note that the shortest side is opposite the smallest angle, and the longest side is opposite the largest angle. So the shortest side, as you can see in this diagram, is going to be opposite of angle C, because angle C is the smallest angle. And in that same triangle, angle B is our largest angle, so the side opposite from it, AC, is the longest side. Okay? So let's look at which sides are opposite which angles. So side AB, line segment AB, is opposite which angle? Well, AB is here and it's opposite angle C. What side is opposite angle A? Well, if we take an arrow from angle A and draw it to the opposite side, we see that BC is opposite angle A. And side AC, as we have in this diagram, we see that AC is opposite from B. Okay? So what this is we're going to be ordering side lengths and angle measures, either from greatest to least or least to greatest. Okay? In this, we're going to do least to greatest, but the problem may ask you for the other way around, so make sure you understand that. So if we look at our side lengths here, we want the smallest one here. Well, this is our shortest side, AB, so it goes first. Then we want our longest side over here in the last spot, which is AC. So that just leaves BC in the middle. Okay. And then your order of your angle measures, they will, whichever angles these are opposite of, will follow in the same order. So C is opposite AB. It's the smallest angle. BC is opposite angle A. And AC is opposite angle B. So that would be the order of the angles. And we can verify that by looking at the diagram. C is our smallest angle. B is our largest angle. And then A is neither the smallest nor the largest, so it's right in the middle. Okay? So let's look at some examples. So number one says to order the angles in triangle WXY from smallest to largest. So we're going to be doing the angles from smallest to largest. Well, if you look at your diagram here, we see that we have some side lengths. Okay. The first thing that I like to do whenever I have a problem like this is I am going to draw arrows from the angles to the opposite sides. Okay. This just tells me which angles are opposite which side lengths. Now, the smallest angle is opposite the shortest side. The largest angle is opposite the longest side. So if we look, whatever order our sides go in from smallest to largest would be the order that the angles would have to go in, whichever ones point to those sides. So if we look here, we have 18, 20, and 22. So our order for that is 18, 20, 22. Which angle points to 18? Well, Y points to 18, so angle Y has to go first. Angle 20 has W pointing at it. And then 22 has angle X pointing at it. So our order of the angles from least to greatest, smallest to largest, is angle Y, angle W, angle X. All right, let's look at number two. Number two wants us to order the angles in triangle FED from largest to smallest. So if we look here, we can see that we actually have two angles that are going to be congruent to one another. if you have two angles that are congruent to one another, you just list them. You just list them together. So you would write like B and E or whatever you have. So we want to order the angles from largest to smallest. So we're going to do the exact same thing. I'm going to draw my arrows. So the largest sides are opposite the largest angles. Well, 19 is our largest side, and then 10 is our smallest, okay? So the two angles that are opposite from the 19s are angles E and angle D. They go together, they're equal, so. And then angle F is opposite of 10. So that would be our order from largest to smallest. So what I want you to do, I want you to try number 3 to order the angles in triangle VUT from largest to smallest. So pause the video and then come back. All right, so with this triangle, again, we're going to draw our arrows. So so we want from the largest to smallest, so we need our largest sides to our smallest side. So 16 is our largest side, then 12 is our next smallest, and then 10 is the smallest. What angle is opposite the side with 16? Well, we have the arrow pointing from U to 16, so angle U. V points to 12, and T points to 10. So angle UVT. All right. All right, let's look at number 4. Number 4 this time gives us angles, but it wants us to determine the order of the sides from shortest to longest. We're doing the exact same thing, just the opposite way we were doing it. This time what we want to do is we want to order our angles from smallest to largest or largest to smallest, and then see which sides correspond, okay? So again, I'm going to take my arrows and I'm going to draw them out. Okay. And I'm going to, since it wants our sides in the shortest to longest, I'm going to write out the angles from smallest to largest. So 42 is our smallest angle. 47 is our next smallest or next largest, and 91 degrees is our largest. Well, which name of the side is opposite from 42? Well, 42 points to this side, right? Which is connected by points X and Z. So this side is XZ. What's our next side from shortest to longest? Well, 47 points to this side, which is connected by Y and Z. And then the final side, 91 points to here, which is X and Y. Okay. All right, same process for number 5. Number 5 wants us to order the sides of triangle WYX from shortest to longest. So we're going to take our smallest angle, which is 40. Then we're going to take our next angles, which they're both 70. So they would go together. So I'm going to draw my arrows. What side corresponds to 40 degrees? That would be WY. What side corresponds with the 70 degrees? Well, that would be YX and WX. So what I want you guys to do, I want you guys to try number 6. Okay, try number 6. All right, so number 6, I'm going to draw my arrows here. And then this one has to kind of go between Those two. Okay. So it wants the order of the sides from longest to shortest. So our largest angle is 105. Our smallest our next smallest angle is 45. And then the smallest angle is 30. The 105-degree angle points to side HG. So that goes first. Then the 45-degree angle points to FG. And then the 30-degree angle points to HF. Okay. All right. Now we're getting into some descriptions this time. Now the descriptions, here's the thing about the descriptions. You want to draw a picture of this and compare it, okay? So for example, number 7, it says in triangle ABC, the measure of angle A is 65, the measure of angle B is 60, and the measure of angle C is 55. Immediately what I would do is I would draw a triangle and label it ABC, and then label your angle measures, 65, 60, and 55. Okay. Then what it wants us to do is order the lengths of the sides of triangle ABC from longest to shortest. Okay. So remember, longest side is opposite the largest angle. Our largest angle is 65. Our next one is 60. And then our last one is 55. What side does the 65-degree angle point to? It points to BC. What side does the 60-degree angle point to? It points to AC. And then 55 points to AB. So that would be our order from longest to shortest. Number 8, in triangle UVW, VW equals 14, UW equals 13, and UV equals 17. So again, I'm going to draw my triangle. UVW, it said VW is 14, UW is 13, and UV is 17. Then it wants me to label the angles from smallest to largest. So you're going to have to order your sides. So the smallest side is 13. The next one is 14, and the largest is 17. Draw your arrows from your angles to the sides. Which angle points to the one with 13? That would be angle V. Which side points to, or which angle points to the 14? That would be angle U. And then angle W points to that one. And then I want you to try number 9, okay? Make sure you pay attention to what it wants from you, whether it wants you to list the sides or the angles in order. All right, pause the video. All right, number 9. In triangle RST, the measure of angle R is 106, measure of angle S is 48, and the measure of angle T is 26. So we have 106 here for R, S for 48, and T as 26. Okay, so we have our arrows here. Okay, so we want to label our sides from shortest to longest. So our smallest angle is 26, our next one is 48, and our largest is 106.
Morning, teachers.
So what we would do here, now we've got 26 points to S and R, so SR. 48 points to RT, and 106 points to ST. Okay, and that's how you list things in order using either the angles or the sides. Okay, so there is a practice worksheet on Google Classroom on this material. Please make sure that you attempt those problems. They are good practice to be able to practice the concepts that you need for the upcoming test. Okay. Tomorrow I will be posting a graded assignment. This would be Wednesday, the 4th November. I'll be posting a graded assignment on this stuff. It's from the both of these videos, so Monday and Tuesday's work videos. And so hopefully you'll be able to get it. If you have any questions, please feel free to email me or join the Zoom sessions, and I'll help you out as best I can. Thanks, guys, and I will see you in the next video.